rapid water loss on Venus. Recent research has revealed that Venus is losing water much faster than previously thought. In this video, we will delve into the history of Venus, the causes of its water loss, and the implications of this phenomenon. Get ready for a journey into the mysterious world of Venus. Venus is one of the most intriguing planets in the solar system. With its dense atmosphere, extreme surface temperatures, and volcanic activity, it has captured the attention of scientists and space enthusiasts alike. However, much remains unknown about Venus's past and the causes of its water loss. In this video, we will explore these mysteries in detail. Throughout history, Venus has fascinated both scientists and stargazers. In ancient times, Venus was known as the morning star or evening star due to its brightness. With the advent of modern astronomy, the position and characteristics of Venus in the solar system have been studied in greater detail. Today we know that Venus has a hot surface, filled with volcanic activity and a thick atmosphere. Venus is named after the Roman goddess of love and beauty. Ancient civilizations observed Venus as one of the brightest objects in the sky. Galileo Galilei's telescopic observations revealed the phases of Venus, showing that it orbits the Sun. In the 20th century, space exploration provided more detailed information about Venus's atmosphere, surface, and internal structure. The atmosphere of Venus is primarily composed of carbon dioxide and covered with thick clouds of sulfuric acid. This atmosphere traps heat from the Sun, leading to extremely high surface temperatures. The surface temperature of Venus is hot enough to melt lead. Additionally, sulfuric acid rain falls from the clouds, but evaporates before reaching the surface. The atmosphere of Venus is much denser than Earth's, exerting about 90 times more pressure at the surface. This dense atmosphere creates a strong greenhouse effect, making the planet's surface extremely hot. The sulfuric acid clouds obscure the surface of Venus, making it challenging to gather information. However, radar and radio wave technology have helped map the surface beneath this dense atmosphere. The surface of Venus is covered with large volcanoes, lava flows, and vast barren terrains. Numerous volcanoes and lava plains are found on the planet's surface. Venus is geologically active, with frequent volcanic eruptions and lava flows. These surface features provide clues about the possibility of Venus having water in the past. One of the largest volcanoes on Venus, Mont Mons, rises about 8 kilometers high and may show signs of active volcanic activity. The surface is dotted with lava flows and volcanic craters. Additionally, there are extensive rift zones and mountainous regions. These geological features indicate the internal structure and volcanic activity of Venus. There are theories that Venus once had water similar to Earth. Scientists believe that Venus may have had oceans and rivers on its surface. However, due to the extreme heat and dense atmosphere, this water evaporated and was lost. Understanding the water history of Venus is crucial for studying the planet's evolution and the causes of its water loss. The water history of Venus suggests that the planet may have had a more temperate climate and water bodies during its early formation. However, the increasing greenhouse effect over time caused the water on the surface to evaporate and be lost to the atmosphere. Scientists search for traces of water vapor on Venus's surface and atmosphere to understand its water history. The first clues about water loss on Venus were obtained through NASA's Pioneer project. The Pioneer Venus probes collected important data by examining the planet's atmosphere and surface. These data showed that there was very little water in Venus's atmosphere, and that this water had gradually disappeared over time. The Pioneer project was a significant step in investigating water loss on Venus. Launched in 1978, NASA's Pioneer Venus project consisted of two main probes, Pioneer Venus Orbiter and Pioneer Venus Multiprobe. These probes studied Venus's atmosphere, magnetic field, and surface. The Pioneer Venus Orbiter detected very small amounts of water vapor in the planet's atmosphere, suggesting that Venus may have had water in the past, but lost it over time. The European Space Agency's (ESA) Venus Express mission provided a more detailed examination of water loss on Venus. Venus Express studied the planet's atmosphere and magnetic field, revealing an acceleration in water loss. This mission provided important data for understanding the causes of water loss on Venus. Launched in 2005, Venus Express provided detailed data about Venus's atmosphere and surface. The mission detected the loss of hydrogen and oxygen in the upper atmosphere, indicating that water molecules were being broken apart and escaping into space. The data from Venus Express showed that water loss on Venus was accelerating and was linked to solar winds and the lack of a strong magnetic field. Various scientific methods have been used to examine water loss on Venus. These include atmospheric analyses, magnetic field measurements, and geological studies. Scientists analyze these data to determine the rate and causes of water loss on Venus. Atmospheric analyses measure the amount of hydrogen and oxygen in Venus's upper atmosphere. Magnetic field measurements help understand the impact of solar winds on Venus's atmosphere. Geological studies examine traces of water vapor and volcanic activity on the planet's surface. These methods are combined to conduct a comprehensive analysis of the rate and causes of water loss on Venus. There are several reasons for the acceleration of water loss on Venus. These include the planet's dense atmosphere, high surface temperatures, and lack of a strong magnetic field. These factors have contributed to the rapid water loss on Venus. Venus's dense atmosphere traps heat from the sun, causing water to evaporate more quickly. High surface temperatures further increase the rate of water loss. The lack of a strong magnetic field allows solar winds to directly impact Venus's atmosphere, causing water molecules to escape into space. These factors combine to accelerate water loss on Venus. The weak or absent magnetic field of Venus plays a significant role in the planet's water loss. While Earth's magnetic field prevents the stripping away of its atmosphere by solar winds, Venus lacks this protective mechanism. This allows solar winds to more quickly carry water from Venus's atmosphere into space. The magnetic field is critical for protecting a planet's atmosphere. Venus's weak magnetic field leaves its atmosphere vulnerable to solar winds. These winds carry water molecules from the atmosphere into space, accelerating water loss on Venus. Earth's strong magnetic field protects its atmosphere from solar winds, while Venus's lack of this protection accelerates its water loss. Solar winds are streams of charged particles emanating from the sun. The weak magnetic field of Venus allows solar winds to directly impact the planet's atmosphere. This impact causes water molecules in the atmosphere to escape into space. Scientists conduct detailed observations to study the role of solar winds in Venus's water loss. Solar winds break down water molecules in Venus's atmosphere into hydrogen and oxygen atoms. These atoms escape the planet's gravity under the influence of solar winds, spreading into space. This process accelerates water loss on Venus and reduces the amount of water in the planet's atmosphere. Scientists use various observational tools and methods to understand the role of solar winds in Venus's water loss. The active geology of Venus is another factor that accelerates water loss. Volcanic eruptions and lava flows vaporize water on the planet's surface, causing it to escape from the atmosphere. The geological activities of Venus suggest that the planet may have had water in the past, but lost it quickly due to these activities. Frequent volcanic eruptions and lava flows occur on Venus's surface. These volcanic activities cause water on the planet's surface to evaporate and be lost to the atmosphere. Additionally, volcanic gases released into the atmosphere enhance the greenhouse effect, raising surface temperatures and accelerating water loss. Scientists study Venus's geological activities to understand their role in water loss. The rapid water loss on Venus has significant implications for the planet's future condition and climate. Water loss can further thicken Venus's atmosphere and increase surface temperatures. This situation negatively affects the planet's potential habitability. Scientists continue to study the future effects of water loss on Venus. Water loss can make Venus's climate even harsher, turning it into an extremely hot and dry planet. This reduces the likelihood of any life forms existing on the planet. Additionally, water loss changes the chemical composition of Venus's atmosphere, affecting the overall structure of the planet. Scientists use various models and simulations to understand the future effects of water loss on Venus. Venus and Earth are similar in size and position, but they show significant differences in water presence. Earth can retain water due to its strong magnetic field and favorable atmospheric conditions, while Venus lacks these protective mechanisms. This section will explore the differences between the two planets and how Earth can retain water. Earth retains water due to its strong magnetic field and favorable atmospheric conditions. The magnetic field prevents the atmosphere from being stripped away by solar winds, while appropriate temperature and pressure conditions keep water in liquid form. Venus, on the other hand, cannot retain water due to its weak magnetic field and extreme hot atmosphere. These differences lead to significant variations in water presence and potential habitability between the two planets. The rapid water loss on Venus affects the potential for life on the planet. Water is a fundamental component of life, and the presence of water indicates the possibility of life. The water loss on Venus reduces the likelihood of life existing on the planet. However, the fact that Venus is believed to have had water in the past suggests that life may have once existed there. The presence of water on Venus in the past suggests that life may have once existed on the planet. However, water loss and extreme temperatures may have caused these life forms to disappear. Scientists continue to search for signs of life on Venus's surface and atmosphere. Future space missions can provide more information and help us better understand the potential for life on Venus. The climate of Venus has undergone significant changes from the past to the present. Once a cooler planet with water, Venus has become extremely hot and dry over time. These climate changes are one of the main reasons for the planet's water loss. Understanding the climate changes on Venus is crucial for studying the planet's evolution and water loss. The climate changes on Venus suggest that the planet may have had a more temperate climate and water bodies in the past. However, the increasing greenhouse effect over time has turned the planet's climate into an extremely hot and dry state. These changes have accelerated water loss and reduced the likelihood of life on the surface. Scientists continue to study Venus's climate changes to understand the planet's evolution and water loss. Future space missions will focus on examining the possibility of finding water on Venus. NASA and ESA are planning new missions to Venus. These missions will investigate the planet's surface and atmosphere in greater detail to explore the possibility of finding water. Understanding the water loss on Venus and the presence of water is crucial for these missions. Future missions will search for traces of water vapor on Venus's surface and atmosphere. Additionally, they will investigate the geological structure and volcanic activities of the planet to explore the possibility of finding water. These missions will help us understand the past and present presence of water on Venus and provide more information about the causes of water loss. The exploration of Venus is of great importance for future space projects. Scientists are planning new projects and missions to better understand Venus's water loss and evolution. These projects will provide important data for solving the mysteries of Venus and understanding the causes of the planet's water loss. Space agencies such as NASA and ESA are planning new missions to Venus. These missions will investigate the planet's surface and atmosphere in greater detail to explore the possibility of finding water for life on other planets. The water loss on Venus provides important information about the evolution and atmospheric processes of planets. This information helps us understand the possibility of finding water and the potential for life on other planets. Additionally, the water loss on Venus provides important clues about atmospheric and geological processes on planets. Scientists study water loss on Venus to better understand the dynamics of the universe and the evolution of planets. The rapid water loss on Venus provides important information about the planet's past, present, and future. In this video, we explored the causes of water loss on Venus, the atmospheric and geological features of the planet, and future research directions. The quest to solve the mysteries of Venus and understand the planet's evolution continues. The water loss on Venus helps us understand the planet's climate, atmosphere, and potential habitability. This information is crucial for understanding the dynamics of the universe and the evolution of planets. Scientists continue their efforts to solve the mysteries of Venus and understand the causes of the planet's water loss. Thank you for joining us on this journey. See you in our next video. Goodbye.